Hi, in this lab activity, we will implement single area OSPFv2 in both point-to-point and broadcast multi-access networks. About the background, now we are helping a network engineer test an OSPF setup by building the network in the lab where we work. We have interconnected the devices and configure the interfaces and have connectivity within the local LANs. And our job is to complete the OSPF configuration according to the requirements left by the engineer. And we will use the information provided and the list of requirements to configure the test network. When the task has been successfully completed, all hosts should be able to ping the internet server here. Firstly, we will use a process ID of 10 for Ospf activation on all routers. Now we activate Ospf using network placement and inverse mask on the routers in the headquarters network. And here, the headquarters router P2P1, and it's connected to 3 networks, the first, the second, and the third one. So we can configure it. Enter the configuration mode, and then the router OSPF 10, then and network, the first one 10.0.0.0 and the wildcard mask area 0 network, .3 area 0. The second network here, we will change the network address and keep the inverse mask or wildcard mask. And the third one here, we change the network address 12. And next we will configure OSPF on P2P2 and P2P3. For example, on this router, it connects to 4 networks. The first one, the second one, the third one, and the fourth one. So we do the similar step on like we had just configured on P2P1. Next, we will activate OSPF by configuring the interfaces of the network devices in the data service network where required. The data service network here, and we will configure the Bc1, Bc2 and Bc3 routers. On Bc1, Bc1 connect to this network and to this network, and Bc1 has the internet connection to the ISP, but we shouldn't configure OSPF running on this interface, the serial 0/1/1, because it's the S interface to the internet. We only configure OSPF on the local interface. The first one is serial 0/1/0 and the gigabit Ethernet here. Okay, so I configured router OSPF 10 network 10.0.0.12. area 0. And the next one 10 0 1 0. We can see the seed log message, the agency on serial 001. It's the P2P1, the headquarter router have the established the neighbor with this router. 10 0 1 and 0, and with the wildcard mask is /29. It's how it mean 8. Oh sorry, it should be 7. Should be 7. Next, we will configure OSPF on Bc2 and Bc3. The first network here, Bc2 connect to this network. So I enter the network command here, area 0. The second one is the network 129.168.4.0 and /24 mean 000 area 0. So it's a OSPF configuration on Bc2. On Bc3 we do the same configuration for the two network. So first one is 10.0.1.0, and the second one we can enter the command and ignoring the log message. And here we can see the agency notification from the neighbor router. This one is Bc2, and this one neighbor, or we have the neighbor of 64 network. So, and we check for the router has its IP address. It's the IP address of Bc1 router. So OSPF will take the highest IP address for the router ID. So now on the requirement here, we have to configure router IDs on multi-access network routers. Bc1 now to configure router ID. And we should use the clear IP OSPF process command for this to take effect. So I will clear IP OSPF process. Reset on, yes. Okay. And Bc2 5 do router id 5.5.5.5 and we clear IP OSPF process and yes, and Bc3 4444 Bc3 router ID 4.4.4.4 and we do clear IP OSPF process. Yes. So after some second we get the syslog message to have the neighbor the router Bc2 and Bc1 here, and we can show the neighbor, show IP OSPF neighbor, and we get the result of two neighbors. This Bc1 here and this is Bc2, and for example on Bc1 we show IP OSPF neighbor we have three neighbors on Bc1 because Bc1 connect to the headquarter routers. So this is the router ID on the headquarter routers P2 P1. Next we will configure OSPF so that routing updates are not sent into networks where they are not required. So on this on the network of data services, we can see Bc2 we will set the gigabit 000 to passive interface, so the hello message will not send out this interface. It's similar to Bc3, we will set this interface 000 to passive interface. For example, on Bc2 router OSPF10 and passive interface we set 000. We do the similar step on Bc3, and on headquarters network we will set the LAN interface on P2 P2 as passive interfaces, and on P2 P3 we will set this gigabit interface as passive interface. So that is your job to do that job. Next, we will configure router Bc1 with the highest OSPF interface priority so that it will always be the designated router of the multi-access network. And here we have Bc1, Bc2 and Bc3, and each router has one interface to connect to the switch, and this interface has a priority parameter. For example, on Bc1 we enter the command show IP OSPF interface gigabit 000 and we check for the information here. This is the process ID, the router ID, the network type, and the priority here. The priority is 1, is the default value on the interface that is joined into the multi-access network for the OSPF process. And next we will check for the Bc2 on gigabit 001. to show IP in the OSPF IP OSPF interface 1, and here we get the priority of this interface is 1. So now we will change the default value on this interface for the BC1. So the BC1 always will be always designated router. So I will change it to number 2. So interface router OSPF10 IP OSPF okay, we will enter the configuration mode and the interface gigabit 000 on BC1 here, this interface, and then we enter the IP OSPF priority 2. Now I show IP OSPF interface gigabit 0/0/0, and now we see the priority on this interface when joining to the OSPF process. So it will get the higher value than the interface on Bc2 and Bc3 that is connected to this switch. So Bc1 will be always a designated router. Next, we will configure a default route to the ISP cloud using the exit interface command argument. So on Bc1, the exit interface should be the 0011. So I will configure it. IP route at 011, and we can ignore this message because the connection to the ISP cloud is a point-to-point connection. Next, we will configure on BC1 to automatically distribute the default route to all routers in the network. So I enter router OSPF10 and we enter the default information originate, and then we will check for that information that is propagate to the P2P1 or not, and show IP route. And here we can see we have the default route from BC1 here and through the OSPF message, and on P2P2 show IP route. We also get the default route, and we check on the data service network on Bc2 and here the default route that is propagate from Bc1. Okay, next we will configure the OSPF router so that the gigabit Ethernet interface cost will be 10 and the fast Ethernet cost will be 100. And to do that, we should review the formula for OSPF cost calculation. The interface cost equal to the reference bandwidth divided to interface bandwidth, and the default reference bandwidth is 100 megabit per second or 10 power 8. Then the default interface cost should be 10 power 8 divided to interface bandwidth. So this means for 100 megabits fast Ethernet will have the cost of 1, and furthermore all interface with higher bandwidth, for example the gigabit Ethernet or 10 gigabit Ethernet, all should be a cost of 1. So we need to change the reference bandwidth. So we will get the more granular cost value. So turn back to our topology on Bc1. I will change the reference bandwidth router OSPF10, and I enter the auto cost reference bandwidth, and on the activity the gigabit Ethernet interface should be 10, and I question mark the reference bandwidth in terms of megabit per second. So I will enter 10,000 megabit per second. So then when we divide it to 1 gigabit, so we will get the reference, we'll get the cost of 10. And this warning OSPF reference bandwidth is changed, ensure reference bandwidth is consistent across all routers. So we should enter the configuration consistent on Bc2, Bc3 and other routers. And then after configuring, we should do show IP OSPF interface gigabit 0/0/0, and you see here this interface has the cost of 100. Why 100? The reference bandwidth change to 10,000 divided to 1,000 megabit, so we get 10. So why is here 100? There's something wrong here. So maybe I change auto cost reference bandwidth to 1,000 megabit. It means 1 gigabit, and do show IP OSPF interface 0/0/0 on Bc1. The cost now is 10. So why is 10? Something wrong here. So this I think there's something wrong on packet tracer when calculating the cost of the gigabit Ethernet. When we set the reference bandwidth at 1,000 megabit per second, divide to 1 gigabit, it means 1,000 megabits. So with all this, we will get the cost of 1, not 10. I think there's something wrong here. Okay. So next we will configure the OSPF cost value on P2P1 interface serial 0 to 50. Then I will enter the config router OSPF 10. and then we auto course no. Also let me check. We should enter the interface mode, interface 00 011 IP OSPF course 50. That is. And the last requirement, configure the hello and dead timer values on the interfaces that connect P2P1 and BC1 to be twice the default values. So the hello timer default value is 10 seconds and the dead timer is 40 seconds. And now we should configure to 20 and 80 second. Okay, so P2P1 0020 interface at 020 IP OSPF hello time hello interval 20 and that's interval is 80. And the 0010 at 010 IP OSPF hello time interval 20 IP OSPF that's IP OSPF that interval 80. We see we get the syslog message to notify us that the neighbor is down because the hello interval and the dead interval is not similar to each other. So after configuring, we get the message to notify us that the loading is too full and loading done. So that is all for this activity. Thanks for watching.